Hey, good morning. Happy Wednesday. And again, and we've talked about this a couple of times, but if you are a nicotine user, cigarette smoker, vapor, or a cannabis user, we could make this a weedless Wednesday, just for a change. And that's an interesting concept because if you're really used to doing something, you get so used to it that you think that it's normal. And sometimes changing things up is a pretty useful thing to do. Anyway, that has nothing to do with what I wanted to talk about today. Well, it has a little bit to do with it, but not a whole lot. What I want to do today, I've got a little presentation that I like to do. It's on the genetics of addiction and some of the brain stuff that's involved with that. And I think that's probably a useful thing to take a look at now because, and we were talking about this the other night on the Recovery Hour show, when people have so much more time on their hands, when things have changed for them, it's pretty easy to slip into doing something more than you used to do it, than you are used to doing it, because we have fewer constraints on us in some ways. We have more in some ways and fewer in the others. So if you are at home a lot and are maybe drinking a little bit more, smoking a little bit more, or using a different drug of choice a little bit more, that can develop into a problem much more quickly than we think. We, our brains develop patterns really quickly. And if it's a pattern that we don't really recognize as a problem, that can sneak up on us quite quickly. So anyway, I want to talk about, I'm going to share a screen with you here. And this always is a challenge for me. I can't really talk at the same time as I'm doing this. And I need to go to slideshow. Yes, I'm talking to myself, sorry. From the beginning. Okay, so genetics and addiction. There's been lots and lots of discussion about the genetic end of addiction and why it seems to run in families. And so I pulled together a little bit of stuff here. Some of it is a little bit confusing, some of it is a bit amusing, and most of it's really interesting. And if we look at the family piece, like I know when I shake my family tree, there's people with addiction falling out of it all over the place like leaves in the fall. And that's pretty true for most people who have a substance problem. There's lots of other family members that have that same issue. And so we start looking at that, and is it nature or is it nurture? And I think it's probably some of both. But we'll go through this and kind of have a look at some of that. So here's a little video on monkeys, which is kind of a good way to start, because we, in some way, shape, or form, originated with them.
This is the sleepy island of St. Kitts in the Caribbean. "300 years ago, velvet monkeys were brought here from West Africa along with slaves serving the rum industry. Escaped monkeys acquired a taste for alcohol by eating fermented sugarcane left in the fields. Today, they satisfy their thirst by raiding local bars. They have learned to be sneaky. Picking the right moment is everything. For years, the monkeys have been studied for insights into our own drinking habits. Just as we vary in our taste for alcohol, so do the monkeys. Some do anything for an alcoholic cocktail. But just as some people are teetotal, so are some monkeys. These reject alcohol in favor of soft drink. Significantly, the percentage of teetotal monkeys matches the non-drinkers in the human population. In line with human habits, most drink in moderation. 12% are steady drinkers, and 5% drink to the last drop. This similarity between us shows that a liking for alcohol is determined mainly by our genes. After each daily raid, other human parallels soon appear. But unlike us, monkeys that are heavy drinkers make better leaders, respected by other monkeys. They seem to tolerate leaders that monkey around. Like monkeys, our taste for alcohol began when we scoured the forest for ripe fermenting fruit. Food and alcohol became linked with intoxicating effect.
So maybe this is all part of a big evolutionary, no, this is stuck for some reason, evolutionary plan. So there are some genetic markers that are worth taking a look at. So to be totally honest, I don't really understand this stuff. I need somebody way smarter than me to talk about this stuff in a little more detail. But there's an A1 allele of the dopamine receptor gene, DRD2, is more common in people that are addicted to alcohol and cocaine. So they've done lots of research on brains of people, and that's one marker that's different. Mice with increased expression of the MPDZ gene experience have less severe withdrawal symptoms from sedative or hypnotic drugs such as barbiturates. And if you transfer that into alcohol issues, people that don't have severe hangovers but drink a lot tend to develop more drinking problems than people who get really sick. And so that's a genetic difference. Mice without the cannabinoid receptor gene CNR1 are less responsive to morphine. And so, a genetic difference there. Mike, there's probably a lot of mics out there that this is applicable to too, but mice lacking the serotonin receptor gene HTR1B are more attracted to cocaine and alcohol. So that's a difference that would have to do with how they respond to things. Mice bred to lack the B2 subunit of nicotine cholinergic receptors have reduced reward response to cocaine. And that's an interesting piece too, because they've been working on a vaccine to help reduce cocaine addiction. It works differently than this, but some people just aren't interested in cocaine. They've tried it, and that doesn't do anything for them. Other people get a huge response from it, and that's a genetic difference. Mice with low levels of neuropeptide Y drink more alcohol, whereas those with higher levels tend to abstain. And that's what they were talking about with those monkeys. And if you match the human demographics, there's about 10% of people who will have heavy drinking problems. There's another 10% of people who have absolutely no interest in drinking at all. And then the other 80% of the people, there's a bell curve between those, or I guess not a bell curve, a slope. that go from high to hardly any drinking. 80% of the population really doesn't have a problem with alcohol, and uh, so the higher use people, that bottom 10%, drink a much higher percentage of alcohol than most people do. Fruit flies, not that we're worried about fruit fly alcohol use, but fruit flies mutated to be unable to synthesize tyramine remain sedate even after repeated doses of cocaine. So you can genetically modify something so it doesn't react to a drug. Mice mutated with defective PR2 gene drink 3 times more alcohol than normal. So that's a genetic difference. Non-smokers are more likely than smokers to carry a protective allele of the CYP2A6 gene, which causes them to feel nausea and dizziness from smoking. And again, if you have an adverse reaction to something, if something doesn't feel good, you're less likely to do it. If something does feel good, you're much more likely to go back to it. And alcoholism is rare in people with 2 copies of the ALDH2 gene variation. So they've looked at lots of different combinations of things, and there certainly is a genetic component to this. I've also talked about the environmental component, and people who are highly stressed, who come out of highly stressful environments, are more likely to develop substance problems because those substances uh, uh, reduce the effect that they're of the stress that they're feeling. So again, when we're in these difficult situations that we are in with way more time on our hands, it's important to be really careful about how much you're using a substance to change how you feel. I know I was talking to somebody a couple of weeks ago who was a smoker, but their smoking has significantly increased. And again, we develop tolerance, we go into withdrawal, and we use more and more of that drug to try and get ourselves back to feeling okay. Mice lacking the CREB gene are less likely to develop morphine dependence. So again, a genetic difference that is characterized in opiate dependence. And I know, and I talked about this when I was talking about cannabis. Some of the work that Yasmin Hurd has been doing has indicated that that parents who are cannabis users, their offspring are altered a little bit, and so they have a higher likelihood of developing a substance problem. And the research that she did kind of moved that substance problem more towards opiate dependency. And so this fellow, Bernie Noble, is an interesting guy. He does research on mice, and I have to start this and then jump ahead a little bit because we'll look at this part another time.
Certain people born to be addicts. Most of the work in this area has been done on alcoholism. Scientists have been helped in the research by a curious breed of mouse called C57.
We give the mouse a 2-bottle situation. In one bottle, we got 10% alcohol, and the other one, they have water. We give this to the animals in single cages, and the next day, we measure how much alcohol they drank and how much water they drank. And C57 mice, they don't hardly touch the water bottle. They go entirely for the alcohol. In fact, they get such high levels, they actually begin to stagger.
Despite their name, C57 are just a normal breed of common house mouse. While most mice are teetotal, for some reason, C57 prefer alcohol to water.
What does the mouse experience? It's brought up in a cage. It doesn't have TV advertising. It doesn't have brothers and sisters who are telling it drink or don't drink. It doesn't have a father who's abused it. It doesn't have all this other environmental factors that have been thought somehow to relate to why some people drink. They're brought up in a simple environment where there's the cage, there's the food, there's alcohol, there's water. Everything is the same. So the only thing that is different is what's inside the animal. It's genes that are getting it to drink or not to drink.
It's all very well studying mice, but could genes for alcoholism ever be found in humans? Ernie Noble has dedicated his career to searching for this gene.
One here. That's the one that contains the brains of the alcoholics, right? Yes.
Freezer full of brains. That's what you want to
We are
watch
fortunate
before lunch.
because we had been gathering brains from the Brain Research Bank here of alcoholics who had died, severe alcoholics, and controls who are non-alcoholics. So we decided to get these brains and examine them for genes that might be involved in alcoholism.
They took samples of brain tissue and carried out genetic tests on them. When the gene results from alcoholics were compared with non-alcoholics, something remarkable appeared. A particular gene, the double band shown on the left, was common to most of the alcoholics. This gene plays a crucial role in controlling dopamine.
I was absolutely flabbergasted in terms of the gene, the dopamine receptor gene. None of the others showed any association. But it was so highly significant that we repeated the experiment to make sure we weren't half-crocked, and it came out the same way.
The results
Flabbergasted.
are
is a great
controversial,
word.
but if true, it means that people who possess the gene have a greater risk of becoming alcoholic. In Brisbane, Australia, Ernie Noble's theory is being put into practice. Vincent has a family history of alcoholism.
On my father's side, it was just rampant right through. All his sisters, his cousins, his own father and grandfather, and unfortunately, I recognised it coming in myself.
Vincent has struggled with drink all his life. His DNA was tested at Ernie Noble's lab, and sure enough, he has the gene, making him vulnerable to alcoholism.
Many, many times I was actually drinking, but I was in a complete blackout. You could be in a blackout or a semi-blackout for, a couple of weeks. Forget even where you live sometimes. Yeah.
Having the gene doesn't absolutely make you become an alcoholic. It shows that you have a tendency or a trend or a proclivity to become an alcoholic.
Vincent's been going to the Royal Brisbane Hospital. He's undergoing experimental treatment that for the first time distinguishes between the alcoholics that have the gene and those that don't.
Hello, Ross.
It was hoped that those with a high-risk gene, such as Vincent, would do much better on a drug that specifically bolsters the dopamine system. The idea seems to work.
I can't put my finger on anything definite, but the treatment did it. But it sneaked up on me, it sort of, and it just changed me.
I think it's given you the stability in your life and a bit of an opportunity to do something, but it was up to you to really do the hard work.
That's right, yeah. If they hadn't have put me on that program, that would have been the end of me. I wouldn't be sitting here today. If the alcohol hadn't have killed me, I'd have killed myself. I started when I was 18. I'm 68 today, and that's a pretty long time, And for me to just be able to turn my back on drink and not have it bother me in any way is just a miracle. It's just remarkable.
Alcoholism is not a uniform disorder. They're genetic type, environmental type. Now we treat both the same way. I think you will see as this research begins to develop and grow, soon we will identify a certain type of alcoholics with genetic type and treat them with pharmacological agents. And the other type, environmental type, will be treated with other kind of approaches.
This program doesn't suit everybody. I mean, you've got to be genetically positive to the particular DNA test. But even if there's 4 out of 10 people that it can help, I can guarantee it will give them a real decent chance at life, you know, and especially if they can get it earlier than I did.
Yes, early identification is really important. I don't know why this never works the way it's supposed to. There we go. So that's a really interesting video. I really I liked what Ernie Noble said about the mice. Like they're not impacted by their environment in particular. Although I don't know how many like sort of mice recreation activities were in their little cages, but they weren't raised in abusive environments. Like you said, they weren't watching TV advertisements encouraging them to drink. They didn't have brothers or sisters encouraging them to drink. Some of them just liked it. And that's really true with lots of people. Sometimes it's because, like I said before, sometimes it's because it's fixing something. Other times it's a difference in the way our bodies respond to that stuff. And if you are doing something too much, and the too much thing is always the hard part to figure out, because when we like something, it becomes really powerful for us, and it also makes it really difficult to see why it is that it's not okay. It's a reward pathway thing. And so if we take a look at this, where's my trusty laser pointer? These areas in here are all part of the reward pathway, and they're deep inside the brain. They're not really areas that we can think our way into. The thinking stuff goes on out here. And when something's strongly affected in those deeper inner parts of the brain, we don't really recognize what's going on, which is why it's so important to try and stay mindful, to try and stay present in situations so that we can look at what we're doing. And if you have strong desires to drink or drug, if it's something that seems really important to you, and either you're starting to recognize that maybe this is a little bit of a problem, or people around you are starting to recognize that maybe this is a little bit of a problem, one of the most important things that you can do is kind of try and separate yourself from that stuff for a while, so that your brain starts to relax about needing that stuff, so that you can start to think your way through it. So one more little video. This is Nora Volkov, who's one of the world leading scientists in addiction.
What we have known from a lot of work that has happened in animal experiments is that all of the drugs of abuse, whether they are legal or illegal, biology does not make that distinction. They all have a common pharmacological effect in the brain. All of these drugs, they actually increase the concentration of a chemical, dopamine, in limbic areas of the brain. And it is believed that the ability of drugs to increase dopamine in these limbic areas of the brain, particularly in reward centers, is crucial for their rewarding effects and for their potential for producing addiction. Now, why is that so? And again, it's one of those aspects that relates a little bit to randomness of nature, that certain chemical structures, the few drugs that are addictive, because there are not many chemical compounds that can produce addiction. If you think about all of the chemical compounds out there in the world, there are very few that are addictive, but we have gravitated towards them. So why have we gravitated towards them? Is this something that's uniquely human? Well, no, it's not uniquely human. Actually, any animal will gravitate towards these drugs. And why is that so? It is so because our brain is hardwired to respond to pleasure. And this is a very intelligent design by which nature ensures that it will make us do behaviors that are indispensable for survival. And that is survival of the individual and survival of the species. So for nature to ensure that we will go through the behaviors necessary in order to procure the food that is necessary for us to survive, it has linked it to pleasure, to reward. Similarly, as it relates to reproduction, that behavior is associated with reward to ensure that the species will procreate. And so this very, very primitive system of reward, which actually can be identified in flies, is the one that is directly tapped by drugs of abuse. And when you start thinking about it, you start to then recognize why drugs of abuse can produce such a level of havoc in someone's brain, because they can directly, literally hijack that system that evolved over thousands and thousands of years to ensure survival of the species.
Okay, so I'm going to stop sharing this and just come back to me for a few minutes. So, I mean, what she said there, there's a couple of really important things. One of them is, in really simple terms, the name of the drug doesn't matter. You know, I hear over and over again, well, you know, I'm just using alcohol, or I'm just using marijuana, or it's just on the weekends, or anything like that. If we're minimizing the importance of something to us, that can be dangerous. And if we're comparing, well, what we're doing to what somebody else is doing, which is probably worse than what we're doing, that's also dangerous. And so if you're using a just to justify what you're doing, take a look at that, because really, like, nobody can change anything but you. And getting honest with ourselves about how our substance use is impacting us is pretty important. The other thing that she talked about was that hijacking the brain thing. And, you know, lots of people get into blaming people who have substance problems, and you know, saying, why don't you stop, or why don't they stop? Well, when our brain is altered, when our brain is changed, what really has changed is we have lost choice. We've lost the ability to choose what we are doing. And you know, just like getting dragged out of a deep crevasse that we have fallen in, we need some help to get out of there. We also need some help to get out of substance problems. So that's enough for today. Thank you. I'll be back tomorrow. Have a good day. Stay safe and enjoy yourself. Look for the good. Thank you. Bye. I have to do this.